You're listening to Encyclopedia Podcastica, a podcast from the Silicon Valley Skeptics.
Hello and welcome to Encyclopedia Podcastica. I'm Hunter Perrin.
And I'm Matt Courtney.
Encyclopedia Podcastica is recorded in front of a live studio audience. That is our wonderful studio audience today. Matt, before we start the show,
Yes.
I have a waifu.
Waifu.
A waifu.
I've heard of a waifu. This is a waifu.
This is whoops Audacity fucked up. You may have noticed that 2 weeks ago we did not release an episode.
Did notice.
It's because Audacity corrupted some of the audio. So, not some of the audio, the entire audio. Audacity dropped a whole bunch of random clips in the audio. So I'm trying to recover that.
So it's still a work in progress.
Yeah, I will eventually release it, even if I have to use the audio from the cameras, which is terrible audio.
Yeah.
I will eventually release it, and I'm really sorry about not having it ready. But what can you do?
Right.
Okay, so actually, we do have a brand new mixer.
Which is hidden from the camera.
Yes,
So
you can't see it, but it's awesome.
Yeah,
And it's expensive.
But
and
you can see these nice,
it's really
big,
nice.
nice big cables.
Oh yeah,
the new
we
cables.
have bigger
coming out.
cables now because we're connected through
Right.
XLR rather than USB. So it should be more reliable. It's recording right now, and it should be able to record for a while and not drop frames like Audacity does. Frames? Samples. Not drop samples. Frames is video. Yeah.
Yeah.
Okay, so.
All right.
So, Matt, you may notice we have a 3D printer sitting in front of us.
I did notice it because it's large.
On and it's loud and it's sitting
Yeah.
right there. And we had to move our stands so that we could... Our cameras are set up differently because this thing is blocking a lot of us from every which angle.
Right.
But
Okay, so
I'm going to start it.
We're going to start it. See what it does.
Start it. I am going to start it. That was a statement.
Yes.
And we're going to print something. Boom. There it goes.
All right.
Sometimes while I'm printing something... Oh, I just got this last week, by the way, for everyone at home.
Right.
Sometimes while I'm printing something, I will sit there and just watch it, just mesmerized for an hour.
So it's all just stare.
Because usually my prints are pretty big, so they're big pieces, big parts of things. So it takes a long time to print. What I'm printing right now should only take about half an hour. But yeah, normally it takes a lot longer. Something else you might notice is that the spool of filament for this is sitting on top of my microphone stand. The reason for that is that this printer actually came with a spool holder that sits on top of the printer right there. But the spool holder that came with this printer is not big enough to hold the spool that came with this printer. Either of the spools. I got two spools. I got white and pink, and both of them don't fit on that thing because they're the same size. This is a 1 kilogram spool of plastic, PLA plastic.
Wow.
So I could print a lot of things with this. I could print approximately 1 kilogram worth of things.
How
Not
much?
approximately, pretty much exactly.
How much of that is that in pounds?
Oh, look at it go.
I think it's 2.2. Woo!
I'm just gonna sit and watch
It's
it
starting to do
mesmerized.
We should.
Oh, let's start the show.
Yeah. Well,
Yeah.
we already started it. But we kind of apologize to our listeners only who are not going to be able to
they
actually
can't see
it.
this.
Yeah. So showing all that
we're
stuff
a
was
podcast too.
yeah. We're not
Sorry.
just a video cast or.
Well, you know what?
video
Honestly,
podcast.
if you're listening to this, go check it out on YouTube. What are you doing? Watch this on YouTube.
Yeah.
This thing is freaking awesome. You get to see a 3D printer in action, printing something live in front of you while we're talking about how 3D printers work.
Right.
And the
but
history
I
of them.
I want to mention that if you are driving and listening to the podcast,
don't go on
YouTube.
Don't drive in YouTube. That's a bad idea.
Really don't do that. All right.
That's so cool. Okay, you talk about the history while I just stare and watch at this.
It means you won't interrupt me while I'm talking
Pretty
about
much,
history
yeah.
for once. Okay. So the history of 3D printers Anybody know when the first 3D printer was created?
I'm going to guess, based on the other things we've done, I'm going to guess like 10,000 years ago.
1988.
You're actually both wrong.
Okay, real guess.
No.
1974.
Any other guesses? Any other real guesses?
No.
The Greeks. No, I'm kidding. The Greeks didn't do it. Unless you count like stone carving, then it's actually before the Greeks. But, I don't think we're counting that. We're talking about like real 3D printing where...
Stone
where
carving
it's,
is
like,
not
automatic.
3D printing because it is subtractive.
Okay, so then
manufacturing.
ceramics.
That's also subtractive. Actually, that's
that's
molding.
Okay.
But you don't build up like a 3D printer. Here, just
Anyways,
go on.
okay.
I'll stop interrupting you and stare at the print.
No, I
again.
mean this was like it was a good topic, but no, the actual invention, the first like real 3D printers were in the 80s. So what happens is by the early 80s, after like 200 years of the Industrial Revolution, we're getting really good at making things like widgets in large numbers, right? But the problem is, if you're going to do that, you really want to make sure that whatever widget you're making is exactly what you need. Like you can't like make 1,000 of these widgets.
You don't want a duck
and,
and then accidentally print a dolphin. Is what you're saying?
yeah, pretty much. Only they're not printing, right? They're making it.
Yeah, you don't want to
factories.
accidentally make a dolphin mold when you meant to make a duck mold.
Right, and then make
Like,
a million.
I meant to make a
dolphins.
bunch of duck decoys, but I got all these dolphins.
We'll just sell them.
Well.
Sell them to marine people who like dolphins.
So what are you
I don't
going to
know.
do when you need to make sure it's a duck and not a dolphin?
So what you want to do, what people are heading towards is this idea of rapid prototyping. Making a prototype of what they're going to eventually manufacture in large numbers as quickly, as cheaply as possible before getting the factories involved, right? Well, that's basically what the first uses for the 3D printer were. If we can come up with this idea, this ability to just have a machine.
Wait.
What?
It wasn't printing dildos?
Not, well, unless they're prototyping dildos.
I think humans have already been prototyping dildos since the beginning of time. The beginning of humans.
Isn't
like
like
isn't that a dildo prototype?
Yeah, I think like one of the first stone sculptures they found was actually
Was a
like
dildo?
all this.
Oh god.
Yeah, but it wasn't 3D printing, and we're not talking about that stone carving. Although I'd like to at some point. So the 3D printing was basically conceived to be a faster method of prototyping and a less costly method of making prototypes.
Don't mind me, I'm just fascinated by this thing.
And in 1981, Dr. Hideo Kadama of Nagoya Municipal Industrial Research Institute. He's actually he takes this concept of doing rapid prototyping and actually like he doesn't, I think he makes it, but the big deal is he actually publishes his kind of description of a 3D printer. And in this case, he's using a photopolymer material, which I think Hunter's going to go over that sort of. Stereolithography.
I don't know. Is that the resin?
Yeah.
Okay. Yeah.
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 So he's using a photopolymer material that when you expose it to UV light, it hardens, right? So you can actually like build up an object by basically making layers using this UV light to cast a layer of the object one at a time. And well, I guess you'll go over how that works in more detail. I don't want to like go crazy with it. But so it was actually a little bit before, in 1980, May 1980 in Japan, Dr. Kadama applied for a patent for his concept of a 3D printer. So again, I'm not sure if he actually had it built at that point, but he definitely had the whole idea and description down. So he's generally considered like the originator of the idea of a 3D printer. So he applies for a patent.
He called it his dildo prototype machine.
No, that's not what he called it. No, this actually
darn.
gets good because he applies for a patent, right? But he missed applying for the patent. He was a little over a year after I assume he published the original idea. Well, the problem is in Japan, if you only get like a 1-year window after you publish something to get a patent, and he missed it. So he doesn't get the patent on the 3D printer, which is particularly ironic because Dr. Kodama is a patent lawyer and should have known about this. So he doesn't get the patent, but he is credited with the concept of the 3D printer. But it wouldn't be until 1986 when Charles Hull, or Chuck, actually invented a 3D printer for rapid prototyping based on stereolithography, and which he called the stereolithography apparatus. And that's same or similar concept to I think it actually uses the photopolymer material and is able to print the objects in 3D by exposing the polymer to UV light. So he actually, what?
Quick note, one of the file types for 3D models is STL, which stands for stereolithography.
STL?
STL. ST
yeah.
from stereo,
Yeah, I guess
L from lithography.
Well, I question that because Chuck, his stereolithography apparatus is shortened, has the acronym SLA. So that's why.
Well, that would make sense because it's apparatus.
It's apparatus, right.
It's got another word in there.
So you may hear references to SLA, and that's what it is, a SLA 3D printer. So he actually patents it, and he gets his patent in on time, and actually gets a patent for a 3D printer, the first actual patent. A little later, 3D Systems actually is a company that actually releases the first commercial 3D printer and calls it SLA-1. And it is first sold in 1988. So we're actually getting like real 3D printers coming out. And the following year, 1989, this guy named Scott Crump came up with a different and cheaper method, I believe it was cheaper method of 3D printing, and which was called fused deposition modeling. I think that's how it's pronounced. And it's actually, I believe, the type of printer we have right here.
Yep.
Yes.
Yeah, this is depositing fused material into a model.
And Hunter will go over the specifics of how that works later. But it was cheaper, and it actually became much more popular and for consumer grade 3D printers. So you'll see these types like everywhere. And Scott Crump went on to co-found Stratasys Inc., which is a very important company in the 3D printing industry. They became a very big company and bought out a lot of the smaller companies that were doing the commercial or the consumer grade 3D printers. Is your printer made by that company, or do you know?
No, this one is made by. Well, actually, it's rebranded by a company named Monoprice. I don't remember the company that makes it, though.
Okay.
It may have something to do with this IIIP, maybe.
Triple IP?
I don't know.
Maybe.
That's a good question. I should have looked that up before this episode. Hey, before we move on, though, for everyone listening to the podcast and watching the video, I want you to hear the sound that this thing makes. I'm going to try putting my microphone near it. I don't know if that's going to work, but hopefully it does, because this thing sounds really cool. I love that sound that it makes.
It sounds very like electronic-y, like something you'd hear like in the 80s when they were trying to make like robot sounds or something.
When they were trying to make good music. No,
I'm
kidding. I love 80s music.
Okay. Well, it was a good break because I want to do a quick aside right at this point, and I want to take this aside all the way to Mars.
That's
really
distant aside.
Distant aside, yes. I just a little thought, not really experiment, but a thought about Mars. So if you're gonna send something up to Mars, right? How much does it cost per pound to send something up? A rocket, the rocket payload that far?
Approximately 1 Mars per pound price unit.
Yes,
That's
Mars
a unit I just made
per
up.
pound, which is really per kilogram, because we don't do empirical.
Nobody does pounds.
Yeah, nobody does
except America.
pounds. Yeah,
Because America.
it's actually from a quick search on Google. I found $261,000 per kilogram.
Good Lord.
Right.
That still can't buy you a house in the Bay Area.
It might be able to buy you a kilogram of a house in, in the Bay Area. And we're not even on Mars.
Yep.
So if you're going to send something to Mars, you want to send the smallest thing, the least heavy thing to Mars you can. Well, it would actually be really impressive, really advantageous if instead of sending the entire thing, you could send something that could make other things, and even better,
Like a human.
No, we don't.
They can make other humans.
Yeah, okay, fair enough. I was going to say, and a thing that makes other things, but that still works as a human. Right. So, a 3D printer is at least part of the way there. And it was actually this idea of making a thing that makes other things that a Dr. Adrian Bowyer had in mind in 2005 when he created the open source initiative to create a 3D printer that can not only print other things, lots of other things, but can actually build itself, including most of the parts to build it. And this initiative was called a RepRap. So is your 3D printer based on a RepRap?
It's actually based on the Prusa Mendel design, which is a little bit different than a RepRap.
Okay.
But it is a distant descendant of a RepRap.
Okay.
Yeah.
Yeah. So the RepRap is an open source plans basically for.
Yep. I could print a RepRap.
Right. Yeah, you can go online and get all the parts, and you can actually, I think you can print the entire RepRap printer from 3D parts.
You can print all of the structure, except for you need some metal rods.
Right, but I thought you could actually get a 3D printer to do the metal rods, but you'd have to have a special printer.
Not this printer.
And then there were some issues with you could print all the parts, but it's not very good with those, because the printed parts are not wonderful, and there's certain ones that are better to use other parts from. I think, I don't know.
It'd be fine.
Yeah, I heard that the resolution isn't as good as if you actually use all 3D printed parts on it. But
yeah,
maybe.
I think mostly the metal rods and things. There's this threaded rod that I don't think any of the cameras can see it, but there's this threaded rod back here that controls the Z-axis, and that basically determines the resolution that you can print at. If the stepper motor and the threaded rod can't go below 0.4 millimeters, you're not going to get good prints. 0.2 is the maximum that you can print something pretty good at, but you want to be at 0.1 if you want precision parts.
Okay. Well, just want to point out in 2008, RepRap actually released their first version of their 3D printer, which was called Darwin, and so many others. Yeah, so many other 3D printers borrowed from that, or actually just took the plans and made their own versions. And from then on, it was just kind of open season for 3D printers.
That's what open source does. It drives innovation. I love it.
Yeah. So a bunch of other stuff happened, but we'll stop it there. So, Hunter, tell us about the science when you're not mesmerized by this 3D printer.
So first on YouTube, we're going to take a quick break, and you can come back to our second video, which will be the science of 3D printers. And you can see the end of this print right here. But if you're listening to the podcast, you're gonna listen right through the fake break.
Fake break.
Yeah.
Encyclopedia Podcastica is a production of the Silicon Valley Skeptics, an organization dedicated to promoting science and critical thinking. You can find us on Twitter at SVSkeptics or Facebook at facebook.com/SVSkeptics. You can contact us at svskeptics@gmail.com. If you like the show, please rate us on iTunes.